In this video, I will show the characteristic of the NMOS transistor. We can start with the theoretical background. This is the N-channel MOSFET. It consists of gate, drain, source, and base. This is the operation condition for the NMOS. If our gate source voltage is lower than threshold voltage, this NMOS is off. If our gate source voltage is higher than the threshold voltage, this NMOS transistor will be open. As you can see in this graph, if we are increasing the VGS, when VGS becomes greater than threshold voltage, the ID current start flows. Let's simulate this circuit on the Cadence. Okay. File, new, cell view. We have to give the name of this cell, NMOS, test bench, we can say, schematic view, and press OK. OK. Then in this application we will use GPDK90. Go to add part, click this one, and add instance pop-up menu appeared. From the library, choose the GPDK90. From the cell, NMOS 1 volt, press the view symbol, OK, then height, OK. The circuit appears. Now to simulate this circuit, we will bias this circuit. To bias this circuit, press add instance, and from here press analog library. From the analog library, we have to add the DC source. Press VDC, press symbol, height. This will be the VGS voltage, and we add another one for the drain source voltage. OK. Then we will make the wiring. To make the wiring, you have to choose this option, create narrow wire, and press the terminals and connect these terminals. This is the drain. We are connecting the drain, and the body should connect to the source of the NMOS. Okay, we made this connection. Then we have to add the GND symbol, ground. So right here GND, press the view, OK. Then add this component for here, and also here. To be sure it is connected, press and drag the component. OK, it's connected. This is also connected, and this is also connected. OK, I can move to up this component. OK, so give the this voltage as a 1 volt. To open the property menu, press the component and press Q. Then DC voltage 1 volt, and this is the VGS voltage. This VDS voltage has to be greater than the threshold voltage. So for our application for now, we can start by giving the 0.6, for example. OK, now we can simulate our circuit. So actually I will observe this graph exactly, but as a first step I will just measure the current for this node. So we can also add the pin. So V in, we can say. Actually V out is enough. Direction, you should specify the direction. Choose output, name Vout, then add this to out. Okay, press this wire, then connect the wires. Okay, now we can simulate this circuit. If you press the F, it will fit the view. Okay, launch. To simulate, press the launch, then ADL. Okay, then you have to click the analysis tab and right click at here, say edit, and transient analysis. We will do transient analysis. Stop time 100 nanosecond is enough. Then press the moderate, then press OK. For outputs, we have to choose the outputs. Again, come here and right click, choose edit. To choose the signal direct from the schematics, you have to say from design. Okay, then if you press the line, the voltage, you will take the voltage measurement, and if you press the node, you will take the current measurement. To show how it's working, I will choose this one also, but for us it's important the IDS current, so if you have to choose this point. Okay, the purple circle is appeared, it means we are taking the current measurement. Come to settings, outputs, press OK, come to ADL screen and run the simulation. Okay, the simulation appeared. You can increase this window. If you press the V, this cursor is appearing, and as you saw, this is the 1 volt. The output voltage is 1 volt and the current is 35 microamps, so it means our transistor is open. Now we will do the parametric simulation. To do this, we are closing this screen and come here and delete this transient analysis. We will do DC analyze and press the edit, then say DC analyze. You have to say save DC operating point, and since we will increase the DC voltage, you have to say the component parameter and select the component. We will increase the VGS voltage, so we will increase this, press this one. After pressing this one, this menu will pop up and you have to choose the DC. Okay, come here and you have to give the start value. As you saw, the component name is V0, which is this one, and parameter DC. We can start from 0 volt to 1 volt. Okay, press OK, then come again the ADL window, then make the simulation. Okay, for now also to observe this value, we can take the voltage of this point, right click here, then press edit, then from design again, now choose this point. After you choose this point, the color of this line changed. Also at here you can see the color. Then come back, say OK, come to ADL window, now run the simulation. Okay, increase this one. So this is the Vout. Since Vout is DC 1 volt, we can close this one. Okay, this one is the VG voltage, VGS voltage, the red one. We can also close because this this horizontal axis shows us the VG voltage. At the beginning, our NMOS is cutoff region. Then after some point it opening and the current increase. So this is very similar to this graph. As you can see, the VGS IDS graph is similar to this graph. Okay, now I want to simulate also the other property, the other things. This is the, I guess you are more familiar with this graph, VDS IDS graph. This is the conditions for the VDS IDS graph. We are saying VGS minus VT, our overdrive. If VDS voltage is lower than the overdrive, we are triode linear region, which is this region, and this is the current formula for the triode region. If our VDS voltage is greater or equal to V overdrive, we are at the saturation region, which is this region, the saturation region, and our current will be given this formula, V overdrive square. Okay, now I want to simulate also this graph. Return to our Cadence and come back here. Firstly, we can delete this one because it belongs to VGS IDS graph. Now we want to draw the VDS IDS graph. Delete this one. Right click at here, then say edit. Okay, DC analyze again. Save DC operating points and say component parameter. Select the component from design. Choose this one. After clicking this one, this pop-up menu is appeared again. Choose DC value, press OK. Then component name is V1. This one is chosen, and parameter name is DC. Okay. Start from again 0 to 1 volt and press OK. Then come to ADL window again, then press the let this and run. Okay, we can again close this one and this one. As you saw, this graph is very similar to the probably at some point after our overdrive. You can see this graph at this region it is linear triode region, and after this region it is in the saturation region. It is very similar to this one. Since it is short channel device, the behavior of the saturation region is different from our conventional technology. Now we are working with the 19 nanometer, so the current graph is a little bit different from the expected one, which is this one. You can see if we increase the VDS after some point, the IDS stay constant, but in our case is IDS is increasing, and this is because the different physical effects comes into play. Okay, thanks for watching.